Hello everyone, welcome back to Infinity Physics. In the last lecture we had a discussion about image formation by convex lens. Now in this lecture we are going to discuss about image formation by concave lens. So here we will start with infinity. That is, the object is placed at a very large distance. So when the object is placed at a very large distance, that is an infinite distance, we assume that the rays are coming parallel. So here we will consider only two rays, that is first and the last ray. This is ray 1 and all the rays in between here, and then we consider only the last ray. So here the rays are coming parallel, and in case of the concave lens we know that the rays diverge from the focus, means after refraction the rays will diverge like this. Similarly here in case of the concave lens, again the rays diverge from the focus, that is they appear to emerge out from the focus, like we assume that, means it appears that they are coming out of the focus. So now when we trace these rays, see these rays are divergent rays. Now the divergent rays will not meet this side. So how we deal with the divergent ray? We trace them back. So when we trace them back, so these rays, the refracted ray will meet at the focus, they appear to meet at the focus, and hence we get here the image at F1. See here this surface, the ray interact with this surface first, right, and hence this focus is called F1. At F1 on the same side, right, on the same side of the object. Now what is the nature? See, in case of the lens we always place screen on the other side of the object. So here we have object, so we place screen here, but this image cannot be obtained on the screen, and hence this image is called virtual image, because image is on this side, that is on the other side of the object, on the other side of the lens can be obtained on the screen, but on the same side we cannot obtain on the screen, and hence this image is called virtual image, and it is also erect. Virtual images are erect images, means it is upright. If the object is here like this, then its very small image will be here, and size is highly diminished, or we can say point like. Okay, now let us see next case. Okay, now let's see case number 2. So here the object is placed between the optical center and infinity, means anywhere in between. Why anywhere in between? That we will see at the end. See here, the object, suppose we placed it here at this position, right, at this position, then what will happen? The ray, first ray we take, any ray we consider parallel ray. So here the ray is passing parallel, then after refraction it will emerge or it will diverge from the focus. Now we consider any of the ray. Either we can consider this ray which is passing from the optical center, then after refraction it will go without deviation, right. Now see, again these two rays are divergent rays. Now if we trace them back, then we will get the image at this position, right. So here where we are getting the image? Between F and O, that is between focus F1 and the optical center on the same side. And what is the nature? Again this side, so it is virtual and erect because it is upright. And what is the size? Diminished. The size is diminished.
Here in the given picture, we can see that there are different positions of the objects indicated by red arrows, and their corresponding images are indicated by blue arrows. You can see that when the object is beyond center of curvature, that is for the red arrows 1 and 2, you find that the corresponding images, that is blue arrow 1 and 2, are given. Now as you move towards the lens, that is towards the optical center, then you will find that the size of the image increases. Now when the object is placed between F, that is principal focus, and optical center, you will find that for the red arrow is an object and its corresponding image is, it's a blue arrow number 5. So here you can see that as we move from infinite to optical center, the position of the image always remain between the focus and the optical center, and also the size of the image is smaller compared to the size of the object, and the image obtained is always virtual and erect in case of the concave lens. In case of the convex lens, the different positions of the objects and their corresponding images are indicated. When the object is placed at infinite, the image is formed at the focus towards the right side. Now when we place the object beyond center of curvature, that is for the position 1 and 2 indicated by the red arrows, when the object is placed beyond center of curvature, the image is obtained between F and 2F indicated by the blue arrows 1 and 2. Now when you place the object on center of curvature or on 2F, that is indicated by red arrow number 3, the corresponding images, that is blue arrow number 3, is formed on the other side at the same position, and this image is real, inverted and of the same size. Now as you move towards the lens, that is when you place the object between F and 2F, that is for the position 4, 5 and their corresponding images indicated by blue arrows 4 and 5 beyond the center of curvature on the other side of the lens. Here the images are inverted and magnified. Now when you place the object on the center of curvature, that is indicated by red arrow number 6, the image is obtained at infinite, which is real, inverted and highly magnified, which cannot be indicated here. Now when you place the object in between focus and optical center, that is the position of the object indicated by red arrows 7 and 8 and their corresponding images on the same side indicated by blue arrows 7 and 8. You can see that these images are virtual, erect and magnified. I hope you have enjoyed my lecture. Please give your valuable feedback in the comment section. Have a nice day.